This episode of Gauging Quality is sponsored by Heidenhain Corporation, creators of many of the world's most accurate and precise technologies for position feedback, motion control, and metrology.
Welcome to Gauging Quality, the show that lets you ask questions about gauging, calibrations, care and use of gauges. And I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
I'm Craig Howell, owner of CPM Labs in Rancho Cordova, California.
And Craig, you've got a really big lineup today, a lot of information that we're going to cover today about what?
The care, the maintenance, some of the adjustment on your precision tools, a little bit about how to use them.
And these are mostly hand tools, right?
These are mainly hand tools, calipers, micrometers, indicators, the typical day-to-day use tools.
Okay. Now, before we get started, we had a question come into the show during the middle of the week. We don't really have the answer for it, so we'd like to throw it out there to you guys to either email it in now or later. This came from one of our viewers. Are there any classes or courses for calibration coordinators? I do not do any actual calibration, but I do track all calibrated equipment for my company. I am responsible for scheduling the calibration of OEM items, both at their facility and having them come here, as well as all equipment that is either calibrated at our facility on a bi-yearly schedule or sent out for calibration. And you couldn't think of anybody who offered courses on that type of position, technical courses, right? But nothing.
Right. The coordinator, that's quite a job, though. There's quite a bit of scheduling, there's coordination, there's calendaring, making sure the tools are available, not in the middle of being used.
I wonder if there's also any connection to maybe meeting requirements of, what was it, 17025, perhaps?
Right.
That might be part of that job description as well.
That might detail who they use for the calibration.
So, Craig and I don't have an answer for any courses related to that. If you do, help out our viewer. Send in some suggestions or answers to techno-live@qualitydigest.com, and we'll go ahead and forward it on to that viewer. So let's get started.
Well, great. What we're going to cover today is a number of things on using the hand tools, maintaining them. This came from a viewer question. I believe it might have been calipers they were asking about, but how do I properly maintain it? What can I adjust? What should I avoid adjusting? What will cause most of the problems? So we're going to cover, I'm going to sound like a broken record, but cleanliness is going to be at the start of each tool. Clean and deburred. A lot of them have moving parts. A lot of them, the measuring surfaces, if they get dropped or banged, they will get burred on them. So keeping those deburred. Most of the tools prefer to be ran dry. A lot of people, their indication is to put some oil on the tool. Oil will attract dirt, and dirt is 90%. The other 10% seems to be the burrs.
They're running smooth, but then they get gunked up with
very
dirt,
quickly,
right?
and they'll get sticky and gummy. If they're sticky and gummy, usually that indicates they're needing cleaning. We're going to cover the storage. Always we suggest using the box they came in, not leaving them laying out on a mill or a lathe or an inspection bench unless you're using them. And using a light touch, well, actually this is more on the use of them, but a light touch almost in all cases will give you a better reading than cranking down. And these are precision tools. They're not supposed to be abused.
A micrometer is not a C-clamp?
It can be in a pinch, but no, that's not the purpose. We're going to cover some of the tools we used when adjusting and some of the chemicals you should use and some that you should avoid. One example would be acetone. We avoid using acetone. If it touches any of the crystal or glass parts, it can fog them, it can blur them. It's a bad chemical for our use for that sort of thing. We would use isopropyl alcohol, and even isopropyl alcohol, we would avoid hitting they call them the crystals, but on these indicators, a lot of times it is a plastic. So we just avoid that. We keep them clean. We do use a lot of isopropyl alcohol, especially on the measuring surfaces of the tools. So that's something we would use. As far as other chemicals, if they do need some sort of lubrication, on a separate rag we might use one of the different Gage lubricant products, but very sparingly. Less is better. They prefer to be dry.
And I'm assuming most, from what I've seen, most Gage manufacturers also sell some sort of lubricant under their own brand, perhaps.
They do, okay. and they're usually very high quality. These are not WD-40 with a different label on them. These are made for this sort of thing. Sometimes we'll have adjustment screws that we have to adjust, but we don't want them to vibrate loose. So we may use, we use a type of a non-hardening Loctite that is more like a blue putty, and we'll just put a dab on the threads of the screw that we've adjusted.
What number Loctite is that? It's probably
Well, this may not be the perfect one for your use, but for our use, we happen to be using 248.
Okay.
It's a non-hardening. On the rare occasions there is oil needed, which is very rare from your point of view. On the internal, that's a different story. But on the external, again, a good high-quality oil from one of the manufacturers that you know and trust, very sparingly. Always on either a rag, a chem wipe, a needle if you're just going to put a dab. Less is better. The tools really are made to be ran pretty well dry from the outside.
And they're precision tools, so I mean, that's why you can run them dry, is you have very, very polished surfaces in most cases.
Very,
right?
very
Yeah.
good
Okay.
surfaces,
Yeah.
yes. Clean is the whole key. Everything we do, we'll start off by cleaning it. That's before we take any measurements. A lot of times your quality program will need before and after measurements. Cleaning is still something we do beforehand. We're not going to run a dirty, grimy caliper all over our gauge blocks. We're not going to be doing that.
Bad for the
'Cause you
caliper,
wouldn't
bad
be.
for the gauge box. Both,
And you
right?
wouldn't in use.
Okay.
So cleaning will always be the first step. Let's go ahead and start with some of the tools we use. We're going to start with OD micrometers. Everybody seems to use OD micrometers. Different types. I'll probably go over to the Gage cam for most of this, but I'm going to start with just a basic 0 to 1 OD micrometer and show you the surfaces. You're already familiar, but the anvil, that has to be clean. The spindle is the other side. This surface needs to be clean. We'll open it up and clean it with alcohol on a piece of paper. When we close them down, we rarely will close them on themselves. The first thing we will do is close them usually on a piece of paper, just for any oils or dirt or anything you've got, and you don't want to grind that into the tool. So we close it on a piece of paper and kind of pull it out there. And now when we
And that grabs any kind of grime that's left on the...
any final dirt.
Okay.
So now when we close it, it is zeroing right on the line. Now this particular one has the 1/10,000th lines. You can line them up. You would see if it's off. Now all these manufacturers, usually the tool itself will come with some adjusting wrenches. I'm going to show you some of the various adjusting wrenches that come with the tools. These usually are inside. Different brands have different styles, but we stock a number of different ones because we use them constantly. So if it were to need any adjustment, there are several adjustments you might need to do. One of them would be if 0 doesn't line up. Now if this gauge has not been calibrated before, you've just bought it, it's come out of storage, it's not in the calibration system, one of the things you would do after cleaning it is see if 0 lines up. And if it does, you're probably good to use it or get it to the calibration lab. If it does not line up on 0 when it's closed, there's a problem. And the first place we would look before doing anything would be for cleanliness or burrs. We'd be looking in here, hold it up to some light, run on a piece of paper, see if it snags.
Oh, so the reason it's not 0 is because
There's a
it
burr
isn't
or
closing all the way
something.
because there's
Right.
something in there. Okay.
Now some of the tools that we might use to actually maintain these, and we caution, this is used with caution, would be some of the, we have a hard white Arkansas stone that we use. Some on surface plates to remove some of the smeared metal, we use a Cratex, which is a abrasive on a rubberized backing.
You kind of use that on the surface plate, I remember, to clean it, right? Okay.
And the large red Arkansas or India stone that we usually use with a light coating of oil on there. You wouldn't use that on a micrometer at all. If you absolutely needed to because you saw there was a burr, you might use the white Arkansas stone. And how it would be used, if it's perfectly clean and the gauge is perfectly clean, is you would set it on the gauge and go one direction and you'd feel the burr. You're not trying to sand it down, you're not trying to resurface it, you're just trying to remove a burr. So possibly you might want to do that if you have to, if there is a burr. Again, then when you're done, after you clean it and clean it and clean it, you don't want to shut these down on themselves with any dirt or grease. You're going to grind it right in and scratch everything up. We always, you'll find us doing this constantly, we don't have any paper that doesn't have streak marks on it. We will rub it and make sure everything is set and then it's back on 0 again. Another thing that might happen, and this is only for these type of micrometers, this doesn't apply to digital micrometers or disc micrometers, but normal OD micrometers, this thimble rotates, and if it's very sloppy, if you can spin it and it keeps going, it's going to need some adjustment, and this is detailed usually when you buy the micrometer. It'll be on a pamphlet in there, and it's in all the manufacturers' different sheets. I'll show you one that's already been opened up. What this has a split nut that will adjust for wear. If it's too tight, you would loosen it. If it's too loose, you would tighten it, and you would use the adjusting wrench to do that. The adjusting wrench would fit. These normally have a little notch or a dot on them, and you would just insert the wrench in there and just slightly turn it. I mean just slightly, just a touch. This isn't something you'd normally do. This is if there's a problem. There wouldn't be normal maintenance for it.
So again, is this something that you would do? You said earlier a gauge that was not in calibration.
Right.
So this is kind of your own kind of quick and dirty. Let's get it operational,
Let's see if it works.
But you still want to get it to calibration at some point here. Okay.
You do. Now, this adjusting the split nut will not work on digital. The digital micrometers, they actually inside there's a groove and a screw riding on them. The back end does not come off. You're going to break the micrometer if you try to open them up. If a digital micrometer ends up being too loose, it's going to need to go to the calibration lab. We have ways to adjust it, but it's beyond the scope of this program. We wouldn't suggest you open them up. So some of the approaches on use of the micrometers, they usually will have a limiting device on them. There will be a friction thimble. Some will actually have a ratchet on the end. That's to help you and me and anybody else get the same reading. It can still be approached. If you approach it too heavily, you can still get the wrong number, and people will say, well, it repeats. It's repeating wrong. Yes, it will repeat. But what we will do is we'll approach the measurement. As we get near, we'll either move the part slightly or we'll rock the micrometer slightly and really get it down to where it's touching and contacted.
Maybe show that on the gauge cam a little bit closer. Yeah.
Sure. To where everything is right there before we do the final turn. So again, we're a little loose, we're a little cockeyed, so we go in and we just keep going until everything is very, very smooth in contact. A lot of machines will do a final push and then do the reading. And now you'll see the reading is exact. So we're on.
So to recap on that, you get it down to, so there's you can't detect any, let's say no wobble, right? Mm-hmm. And then once you've got it like firm, then you just give it a little bit more?
Final, where you'll activate either the ratchet, the friction thimble or the ratchet, whatever the case is. So that would be some of the use on it. On holding it, a lot of times we'll just hook our finger through it. Everyone has a different approach, but that's very common. Sometimes you can rest the part on your other finger. You know, number of approaches, but how do you hold it? You don't want to hold it like this, you know. Most of the viewers, I'm sure, know how to hold a micrometer, but we do get asked.
Yeah.
So going back to basics is always a good thing. So that pretty well covers micrometers.
Okay.
Next thing we'll cover will be calipers. What do you think the first thing is we're going to do with them? We're going to clean them. Clean them with alcohol. Clean the measure. In this case, this will be the surfaces that everything moves on, which are the rails. These rails here will always need to be cleaned. The jaws, the measuring jaws, always. We always clean both the OD and the ID jaws, the pointed jaws. And somewhat overlooked is the back end, there's the depth rod. And this surface here should be kept clean and deburred, as well as the rod tip. You'd be surprised how bashed up we see them.
Well, I was going to say, I would assume that the rod tip most of the time is mangled.
It is.
I mean, I would assume that.
But mangled can make it read large or small, depending if it's burred outward.
Yeah.
So we'll check that occasionally. If we have to run a stone on them, very cautious. You don't want to just use these stones like sandpaper. It's not like that. So we would clean them. Then what we look for is we will hold these up to light. Once they're cleaned, we should see no gap on the OD jaws at all. No gap at all. When we do, it's usually at the bottom. That's usually from wear. It happens with sheet metal when people work them back and forth. They typically get worn at the tip. The other direction would be if it's an A shape and we can, or I'm sorry, a V shape, we can see a gap up in here and it's touching at the bottom. That's usually a burr. So now very cautiously, if you have to, and if you're familiar with using an Arkansas stone, again, we would put the stone on the surface, feel that it's flat. We're not cockeyed. We're not going at a different angle. And one swipe outward, you'll feel if there was a burr. If there's no burr, stop. You're not trying to sand it. You just want to deburr it. A lot of the ID jaws get damaged. We'll find a lot of damage on these ID jaws. They get dropped, they get smacked, they get worn. Again, with the stone, if you have to, one swipe out. Now these aren't knife edge. A lot of people think these are knife edge. These are actually surfaced. They have some width to them. And that would be something I'll cover on the use of them. When you're using an ID jaw to measure a diameter, if it's a large diameter, that squared in on the round ring is not going to make much a difference. But if you have a very small diameter ring, you might have a little bit of a different measurement than true because you've got a squared surface.
Oh, because the surface is square. I get you. Okay, if it was a knife edge, it'd be different, but
or if it's rounded. And I've seen some calipers, some Swiss calipers actually have rounded ID jaws. I like those. That's kind of a nice approach.
Just a reminder to you guys, if you've got any questions about anything Craig is covering or that he might cover in the next few minutes, be sure to send your questions to techno-live@qualitydigest.com.
Here's one of the essential tools that every good calibration lab has. It's a toothbrush.
Hey, that looks like the one I use.
Typically, dial calipers work on a rack. And there's a rack in here that the gears will ride on. And that rack is just notorious for collecting chips and dirt and grease and oil.
So that would cause the indicator to skip a cog, right?
Skip.
Okay.
And a lot of times when they're not on zero, when you close it and it's at 9 o'clock or 3 o'clock or 6 o'clock, that's what's happened. It's skipped a tooth. So the first thing we will do always is clean these with the toothbrush. We'll just clean out the racks.
Now, just a dry toothbrush?
Yeah. Okay. You do not want to squirt alcohol in here.
Okay.
We will squirt alcohol on a rag and work the surface. But yeah, typically dry. We'll also use the toothbrush on the ends. And then up in this area here, this is where inside there's a little some might call it like a leaf spring. It's called a gib. And it's just usually a brass piece, some use nylon. And it's curved. It keeps tension on this. So when it slides along the rails, there's a little bit of tension. And there are adjustment screws on that gib. We don't suggest using them unless there's a problem. If this rocks back and forth, and obviously is out of adjustment, you might have to go down a little bit. But these screws are typically where we might use a touch of that Loctite if they tend to back themselves out.
Yeah, keep them in place.
But that's just on the screw itself, not inside.
Is there any value, or do you, or should you not use compressed air at all? I mean, to kind of blow...
We don't.
Okay.
We don't, because sometimes that blows the chip further in.
Oh.
But sometimes that might be your only option. If you can see what you're doing and wearing safety glasses,
so you're concerned that you might blow debris into the gauge. Okay, gotcha.
Right. So we'll sort of avoid that. Some minor gib adjustment might be needed, but that's how you could tell is if you're making a measurement and depending on how hard you push, you keep getting a different number constantly. This one's adjusted pretty well. I'm putting tension on here and it's not moving. If that needle kept swiveling, you'd know something's up, and that's usually what happens. The same works for going outward with a inside diameter. If as you, let's try to get this on the camera, as I'm applying pressure outward, if that needle keeps rising and further and swinging back and forth, that might indicate the gib is a little loose. Those are best left to the calibration lab, but sometimes you have no choice. How you could tell if you hold it and vertically, and if it drops, that probably the gib is too loose. But then again, you want to be able to smoothly move it.
Right, so it's kind of that delicate balance between...
Too tight, too loose.
Too light, yeah, okay.
So that covers calipers. Remember, if they have a dial or a little knob here, don't overpressure to get the number you're looking for. It should be more what is the true
You're not supposed to
feel.
force it to be what you want? Okay.
Not intentionally, no. So that pretty much covers calipers.
Now, one of the things that I'm not sure you touched on this, but you told me is that, let's say with calipers or micrometers, is it's not only technique, but it's also repeatability, that you do the same thing every time.
That's a good point. The pressure you apply to any of these, if you do it the same every time, you're going to be miles ahead.
So if they're using like a ratchet type, let's say micrometer, they get to that final little bit and they do 2 clicks or 3 clicks.
2 or 3 clicks, do it for all of them.
Same, yeah, 2 or 3 clicks every time, not 5 clicks one time and 1 click another time.
Right, it's going to help. I don't know if it'll change. I can't give you a quantity. It might change in one division.
It's just consistency.
It is, and consistency is always good with these tools. So indicators, let's talk a little bit about indicators. Indicators typically have the crystal, and they have the contact point. The contact point is the long arm with the ball on the end of it. And the contact points, all the manufacturers make them in different lengths. They're not interchangeable as far as length. You could not put the small contact points on this indicator and have it read linear.
Is that a common thing where people go, oh, I need a longer reach or a shorter reach, and do they just swap out the contacts?
It is. I'll see an indicator box that'll have a 5-inch long tip and a 1/2-inch long tip, and I know they're not getting linear readings. I understand they need them for certain jobs, but you have to have an indicator made for that contact point. So let's cover what we would do on indicators. Clean. You have to keep them clean. Now these also have little dovetails. This is how they're mounted. They have them on the side, on the back. This one has them on the top. They put a little decal of their own. They must never use that particular area. But those dovetails, some of them have screws on the dovetails. This particular brand has screws, so you'd want to make sure these dovetails are tight. This particular brand also has a stem on the back. That has to be tight enough that when the indicator is activated, it's not moving the whole indicator.
What's the stem for?
Staying still. Mounting in the height gauge, mounting, and it does swivel, but there should be quite a bit of tension in order to do that.
Okay.
So 90% of the problem with these indicators will be the contact point, the ball. The ball gets worn. It should be perfectly round. Look at it under a magnifier. You might be surprised. It might be a half a moon, half a ball with a flat on it. Some will have flaps on the bottom and the top, and they need to be replaced when that happens.
Now, what about ball size? Does it matter? Like, I noticed you've got one that has a very small ball on the end and one that has a rather large ball on the end, BB sized.
That is interchangeable, and that will be the user will determine what they need. Some need to get into a real tight place, they want a small one. Some are measuring a large surface, they want a larger. Ball diameter is interchangeable as far, you just have to keep the right length. Okay. That's critical that you do that. Some of the techniques on using these indicators always are made for the contact point to be parallel to the measuring surface. You don't want them way down, you don't want them way up. They should be parallel. Now the actual body can be at a different angle.
Oh, I see what you're saying.
It's the contact point, because it's a lever with a known distance. That's how it all works. Now the one exception, there's always exceptions. One of my favorite indicators, happens to be an Interrapid, it's a Swiss made. They are made to be at a 12-degree downward angle. Don't know why 12 degrees, that's what they've decided. But these will not be linear if you have them straight out. They're not going to measure linear. They are made to be set at a 12-degree angle. Now let me show you on these, what can happen is sometimes you can end up in use, they might get hit from one of the side or the other side, and if the indicator, if you can move this side to side, it should never have any play. That could be an indication that the ball bearing screw has been damaged. We don't really advocate adjusting them, but sometimes you may have to. The contact point is almost falling out and you can see the screw is back way off. This has a locking ring, so that normally how we would do is we would loosen that, bring the screw down until it just touches or almost touches, and then slightly lock the locking ring. You want to avoid doing that. That's best left to people with the proper training. Having the right tools is one thing, but understanding the proper training is something else. The exception to that, for sure, would be these inner rapids. Do not adjust these screws. There's one of the indicator repair parts facilities has a little logo on there that says, you adjust these, you're guaranteed a repair bill. This particular indicator is a 5/10,000ths indicator, and they have the 2 screws on the side, which are quite precision. We do not suggest you touch them.
Now I notice there's no Loctite on those. I mean, I would assume that's something that you didn't want somebody to mess around with, that you might put a little dab of Loctite on there?
You could do that. You could do it. Some would call it a torque stripe or an indicator, a tamper-proof.
Yeah, exactly, yeah. Yeah, that'd be the other thing. You'd know if somebody had messed with it.
You would know.
Yeah, okay.
But occasionally in use, as you know, things happen, and it's obvious what's happened. You know what you need to do. Just approach it very lightly. I would get it to the calibration lab after that. Okay. Now, we get a lot of times people will bring in tools and ask us if we can repair them, and we tell them, well, there are some tools that just can't be repaired. But the point I had with this tool was this particular indicator has the three screws. Do not touch those.
So you couldn't calibrate this one?
No.
No?
No. So those, any of the inner rapids, do not touch those adjustment screws at all. If it needs adjustment, you're best off getting that into the calibration lab or somebody familiar with repairing them. Probably the last thing I'll cover on my little section will be torque wrenches. We get a lot of people with torque wrenches in, and they will ask the proper use. Clean them. What a surprise. This particular type has a little clutch, and you wind it up. When you get to the torque, it'll click. When you're through with that, unwind them. Leave them stored unwound. This is a spring-loaded device. We don't want to leave it compressed.
So that's just what I was going to ask, is why do you need to unwind them?
It's spring-loaded.
So you're leaving the spring in a compressed state?
In a compressed state,
okay.
It's not going to respond the same.
Okay. It's going to kind of have a memory or something, okay.
Eventually, you'll have problems.
Okay.
So we would leave them unwound, leave them in their case, always in their case. That's a good move. The ratchet head itself, that usually is hardened. It doesn't have too much trouble. Some of them, I've noticed, some of the snap-ons say oil regularly. We don't suggest you put oil in them. That, if it's in a calibration lab, they're handling it for you. They should be taking care of that. A lot of these ratchet heads, a gear tooth will break now and then, and you'll know it. It'll be slipping on you. Send it in. Have the gear head replaced. That's probably beyond most of the users to try to get that all adjusted, and they would still need calibration in anyway.
What about using a torque wrench?
Okay, on the proper use of it, these will click and kind of release the pressure when you get to the right torque. But you can do it wrong. If you're too heavy-handed and you're popping it, you're going to get the wrong reading. You won't be getting the correct reading. It's better to, almost like a machine would do, just go to the part. As soon as it clicks, stop.
So an even pressure.
Even
and then,
pressure,
okay.
Even movement. With a dial, that's different. You're looking at the dial. You know you've reached your torque. One thing I would like to show, if we have a moment,
Sure.
I dug into the archives and found the oldest digital micrometer in existence.
While you're dragging that out, just a reminder, you guys, we got about 15 minutes left on the show, so get your questions into us. Techno-live@qualitydigest.com, related to anything that Craig has talked about today, or maybe an unrelated question, whatever you want. Go ahead and toss it at us. If we don't know the answer, we'll either pretend like we do, or we will we'll put it out to our viewership, and hopefully somebody out there will have the answer for you. So.
I'd like to show you one of the older of the Mitutoyo digital micrometers that I have seen in a long time. They still currently make this model. Of course, they've incorporated the digital display into it. But this is really cool.
That's really fancy looking.
The digital display, it's on a little ball socket. You can adjust it. This one happens to be a 2-inch micrometer. It has a 1-inch already in there, so it'll measure 0 to 1 inch with that. You remove this, put in a different anvil. You've basically got a bench micrometer, and it's accurate. We just calibrated this for a customer. It's in use daily.
How old is it?
I don't really know, but boy, it uses 1.5 volt batteries. It uses 3 of them. This is quite old. And this is just a really, really cool. I like some of the older equipment. We get a kick out of it.
Yeah.
But I just wanted to show that the flying airplane. I really like that.
That's pretty fun. That's pretty fun.
So that pretty well covers my end of it.
Okay. Was there anything else you wanted to touch on in terms of one thing? Actually, since we have a little time, show us how to ring gauge box.
Okay, gauge box. Typically, I'm going to go over to the gauge cam. We would be wearing gloves at this point. We don't advocate touching the gauge blocks with your bare hands. But if they are totally clean, these have been cleaned and cleaned, they're perfectly clean. A lot of times, what you will do is you'll put one block on the other, you'll move it out, and as you move it forward, you slightly twist. Now, if there's any dirt, you're just ruining both gauge blocks. But if you can, I don't know if these will ring. They typically, yeah, these have rung together.
Now that's somewhat. I mean, I've tried doing it. I mean, that's somewhat of a kind of an acquired skill as well, ringing them, right? I mean, I've tried doing it. I've never seemed to be able to get it.
When you put them on each other and then you move it out and slide it forward, if you slide it at an angle, you're going to be gouging both gauge blocks. You want to avoid that. That's not for the weak at heart.
Right.
But yeah, we do a slight twisting movement, and you can feel it's almost like a magnetic field. It's not really magnetism, and it's not dirt. They've rung to each other.
Surface tension or something like that.
Surface finish, the surface finish,
okay,
right.
Yeah.
So that's some of the ringing.
Okay. Well, hey, let's take a look at something else here for a little bit. Be sure to get your questions into us, guys. Send any questions related to what Craig's just covered, or else, actually I'm going to cover a quick piece of equipment here right now from Heidenhain. And if you have any questions related to that, go ahead and shoot it to me at techno-live@qualitydigest.com. Okay, so Heidenhain, as we mentioned at the top of the show, is our sponsor today. Heidenhain manufactures a large number of digital readouts and in-process gauging tools and so forth. And they sent us one of their tools. This is called the Gage Check. This is essentially a digital readout. If any of you have ever worked with check fixtures, you know that maybe a typical setup might be you have your check fixture and maybe you have a number of dial travel gauges installed in that check fixture, and you take your part, you put it in the check fixture, and maybe you have 3 or 4 gauges in that fixture. So you got to go around, you got to read and note down each gauge, what the value was, is it in tolerance, is it out of tolerance. Maybe you have to do some gauge math. Maybe the measurement is related to 2 gauge measurements. All of that. It's a very manual operation, a little time consuming, also prone to error. So Gage Check, the Gage Check product is really what addresses this. This accepts, this particular model, this is the ND2100G, accepts up to 8 gauge inputs. We happen to have 2 gauges with us today. These are linear measurement gauges from Heidenhain. And I'll show you just kind of run you through real quick what this does. This happens to be an Acanto gauge. This has got a 2 micron accuracy over the full travel of the gauge, which is, I believe this one is 25 millimeters. And let's take a look at the Gage Check here. So right now, get my finger in the way here. There we go. That's the easiest way. There we go. So okay. So as I'm moving the linear gauge, the digital readout is, you see it's reflecting the travel there. So that's one way of looking at data. We can also go to, let's say, a vertical or horizontal bar display. So this happens to be the vertical bar display. Now notice as I'm moving this, it starts off green, turns yellow, then turns red. So obviously I can program in tolerances for each gauge. So that means that each gauge becomes its own go, no-go gauge. So you can very quickly, if you had multiple gauges, you'd be seeing multiple bars. You could very quickly do a go, no-go check on all of your gauges. We can also look at this as a dial, kind of an analog dial gauge. Notice we've got the digital readout on the bottom and an analog type gauge. Oops, sorry, wrong gauge. There we go.
Ooh, dial fan.
There we go. So you've got an analog type gauge on top. Also notice that it has the tolerances programmed in, so green, yellow, red. And also you have your digital readout on the bottom. Now the thing that makes that makes this type of product really super useful is, like I said, is the ability to do gauge math. So you can do calculations based on readings from multiple gauges, or you can do calculations based on the reading from a single gauge. And I'll show you how simple it is maybe to set up to do run out. So we would come over here. I would go into my menu, and we'll go into Setup. I'm going to scroll down here to Formulas. So I'm going to create a formula for my A measurement. I'm going to delete what I already have in there. And let's program in. First thing I'm going to do is I'm going to say, find my maximum measurement. This is dynamic, so it's looking for the maximum dimension, maximum value from the gauge continuously. And I want to look at my channel 1 gauge. And I'm going to subtract from that the minimum value that it finds on that same gauge. So now my formula essentially is my maximum value that I find minus my minimum value that I find. That is going to be my run out. So now I can simply go back to my display, and we're looking at A. And I've got a little test fixture here. You can see I've got here's my linear measurement gauge right here. I've got a little cam on the bottom. So as I rotate this, you can see the gauge move up and down. And if you look at the value, you can see my value is slowly increasing as it finds the maximum difference between the high value and the low value. So obviously once I've rotated through 360 degrees, I have simulated my run out there. So now I'll simply store that value, and we'll zero it, and we can take another measurement. We'll do the same thing again. So here again, I'm just simply rotating 360 degrees. It is calculating for me, on the formula I put in there, what my run out is. So now I can enter that value. And now let's say, now we want to go take a look at the values that we've stored and maybe some other information about them. Go to View, and I can look at an SPC chart. Notice there's already data in here up at the top. My upper control limit, my lower control limit, I've already programmed in. So we got our little SPC chart there. You can look at a histogram of the data. A channel, B channel, that's the B channel. There's the A channel. I can look at the raw data. So here's all the data I collected on the A channel. I can look at the A and the B at the same time, or I can select just the A or the B. Remember, we only have 2 probes plugged in on this. It does accept up to 8. Another thing that we can do, which is really valuable, if we go back to the, oh, actually we can do it here. These Acanto probes, and I think most of the Heidenhain probes, are smart probes. In other words, there's a chip in there that contains all the information related to the type of probe, the interface, the serial number, so on and so forth. And we can take a look at that very quickly. So I'll go back into my menu. We'll go to Setup again. And I'll scroll down. By the way, any of you who have used a Quadracheck or any other Heidenhain or Medtronic readout will recognize the menu structure. Craig tells me it hasn't changed in about 1 million years.
Not 1983.
Exactly. So okay, here's our channels. So notice up at top, it's telling me what channel I'm currently on. That's C1. If I click on Info, it tells me everything about this probe. It tells me the ID number, the serial number, the name of the probe. This happens to be an AT3018, a Acanto probe.
You can look at the accuracy of the probe, can't
And
you?
you can look at...
It was in there somewhere.
that might be somewhere else. The length of the probe is, oh, this is a 30 millimeter probe. Okay. Step size, 23 nanometers. We can go to diagnostics. The diagnostics will tell me the signal quality for both the absolute encoder and the incremental encoder. And it's telling me that both of these are way into the green. So this probe is fine in terms of signal quality. And we can also look at errors. There's a number of different error codes that come up or can come up if something is going wrong with the probe. I've got all greens here. Tells me this particular probe is fine. I can increment my way up to another probe, and I could step through all my probes and do diagnostics or look at the air quality on them. So again, this is just a very useful tool, particularly if you're using multiple gauges in a setup, and you want to be able to very quickly be able to do a go no go test, or to be able to do complicated math. Particularly, you know, some of you who have where you might be doing two gauges opposed to each other to measure, for instance, thickness. You could do that. And the math for doing that is you just write it all in there. So again, this is the gauge check, the ND2100G from Heidenhain. Thanks Heidenhain for sending that to us. Did we have any questions come in, Chris? Okay, go ahead and put that up. Do you have that available? Okay. What is your opinion for air gauges in today's inspection methods? Should they be retired now, or are they still pertinent in inspection of parts? I myself am very fond of this tool.
I understand that. A lot of tools you get used to, you know how they work. They may have a quirk here or there, but you processed that out years ago. I'd suggest if it's working well, I would keep it.
Well, also, I think when we covered air gauges, there were some real definite advantages to them.
There are.
Particularly in a machine shop, the idea that you're using air is kind of self-cleaning the part, right. Knocking debris out of the way. And they're also really pretty darn accurate.
Very accurate.
Yeah. So, I mean, if you're doing precision measurements and you already have an air gauge, I mean, I don't know why you would switch to anything else.
Keep it calibrated, keep it clean. Well, there are some advantages on the other side of the coin to buying a new one. There are some there are some capabilities they didn't used to have. They do now, but if the tool works well for you and works for your process.
Yeah, and air gauging it's another one of those things. It's a tried and true method. And in fact, there are still, what do I want to say, advancements being done on air gauging, even as we speak. New methods coming out, more accurate methods. I believe, matter of fact, we were just talking to one of the inventors of a type of air gauge just a few months ago, and he's come up with kind of another new solution that uses a different way of how would you say it? A different way of using air gauging to get more accurate measurements than some of the technologies that are being used right now. So, very useful instrument. I mean, I don't see why you would switch it out. So.
I agree.
I think in some cases, it's one of your only solutions, cost effective. I mean, we were talking about measuring the inside diameter of a bore.
Accurate.
Yeah.
Yeah, they have some very good advantages. If it's working well, I would keep it.
Okay. Any more questions, Christopher? Okay. Okay. My company has gotten away from pitch gauges and gone totally to threaded plug gauges. Was this a wise thing to do, substituting an attribute gauge from a variable gauge with actual readings?
There are advantages and disadvantages to pitch micrometers, for instance.
So tell me what a pitch gauge is. So
a pitch micrometer would be a micrometer. Instead of having normal anvils, where you would have here, one will have a V and one will have a cone.
Okay.
And you can check threads at different portions. A thread plug gauge you screw into the tool, and like the question said, it's more of an attribute. It goes or it does not go.
It really is a go-no-go gauge?
Right. They each have their advantages, they each have their disadvantages. I could see why you would want a pitch gauge to check for thread taper. You could see that if they're not easy to use. They're quite complicated to use a pitch mic correctly. But you could see taper. You wouldn't see taper on a go or no go plug gauge. Okay. It either would go or it wouldn't. You would not see any variation on the threaded hole that would stop a fastener necessarily with the pitch gauge, because you're only measuring one point, where a thread plug usually has 5, 10 threads in it. So
you're running it further through? Is that the...
Almost like using a Deltronic pin through a banana-shaped hole. Okay. You wouldn't see that if you were just checking one individual portion, but you do if you insert the whole thing.
Okay.
I think there's value in using the pitch micrometers, the variable, but there's also the final check with a fastener type of gauge, which would be a plug gauge. Okay. It almost simulates a fastener going through.
And what about... is this the same, just a different way of measuring the same thing, the little thread wires?
Thread wires would be for an outside
Right, outside,
not for an
obviously.
inside.
Okay, right, got it. Okay.
And again, there you would use the conflict would be a ring gauge, go and no-go ring gauge, as opposed to measuring over wires. Again, you would see taper, possibly. You could see that form error. You might not see that with a thread ring gauge, except it'd be loose and then it'd progressively get tighter.
Okay. All right. Any more questions, Christopher? Nope, that's it. Okay, well, hey, that's
11:45.
Perfect timing, 11:45. There we go, 45 minutes. Okay, well, thanks to all of you for joining us today. Thanks, Craig, for really a terrific run-through on a whole variety of equipment. Remember, if you have any questions related to this show, go ahead and send them to us at any time. If we get them during the week or during the month, we'll just include them in the next episode of Gauging Quality. Before we go, I'd like to thank once again our sponsor of this episode, Heidenhain. In addition to digital readouts and in-process gauging tools, as we saw today, Heidenhain manufactures encoders, CNC controllers, and measurement systems that help customers improve accuracy, precision, speed, and cost savings. Visit www.heidenhain.us to learn more, and I believe there's actually a banner underneath the player page. You can click that as well, and that will take you out, I believe, to information on the gauge check. If you have any information on the gauge check or any questions on the gauge check, go ahead and send them to us. We'll send them on to Heidenhain to answer those questions for you. So, once again, good show, Craig. Appreciate it, man.
Derek.
Okay, and thanks to all of you for joining us at Gauging Quality, and we will see you next month. So
Thank you.